Morning and welcome to Master Talker online class. In today's video, we'll be talking about plane geometry. Please, if today is your first day of watching our video, please consider subscribing. Okay. Now, before we talk about plane geometry, let's talk about angles. Angles. Okay. Now, the first angle we will talk about is called the acute angle. The acute. Now, acute angle, okay, is any angle that is less than 90 degrees. Okay, that is theta is less than 90 degrees. Okay, so and we represent them like this. You see, this is the theta that is less than 90 degrees. Okay, if here is maybe A, B, C, for example, we call it angle BAC, or we call it angle CAB. But most of the times we use alphabetical order, so we call it angle BAC. So we say that angle BAC. The main angle is the one in the center, which sometimes we call it like this, BAC, indicating that the angle is the one in the center. Okay, angle BAC is equal to what? Theta. Okay, so that is how we represent that. So the second one is called the right angle. The right angle. The right angle. The right angle. And the right angle is always perpendicular to each other. Like this. We represent them like this. So if this is A, for example, B, C, D. Okay. In fact, this side is equally right angle. Anything perpendicular. So we can say that, look at the way we mention it. Don't forget that the one in the middle is the main angle. So we can say angle what? A, C, B. You know, I told you alphabetical, so it's supposed to be A, B, C, but the angle is not B. The angle is the one that is in the middle. So that's why we started this. So yeah, for this angle, the left hand side is what? Angle A, C, B is equal to what? Angle B, C, D, which is this one. Angle B, C, D. Okay, which is equal to 90 degrees. So right angle means that theta is equal to 90. You know, the first one we did is when it is less than 90. So this second one is what? Is equal to 90. So now the next one is obtuse angle, number 3. Obtuse. Obtuse angle. Okay, obtuse angle is is any angle that is greater than 90 but less than 180. So 90 is less than theta, which means theta is greater than 90, and then that theta is still less than 180. Okay, so that is what we call obtuse angle. So obtuse angle will represent obtuse angle like this. That is obtuse angle. You see, if you trace this part now, you get the 90 degrees. So it's already greater than 90, so but less than 180. So theta is here. So if this is A, B, and C, we say that what? Angle A, B, and C, we can represent like this, is equal to what? Theta. And it is what? Obtuse angle, greater than 90 but less than 180. So the fourth one is angle on a straight line. Angle on a straight line. So since the one we did previously is less than 180, so let's talk about the one that is equal to 180. So it's always angle that is on a straight line, and it forms a semicircle. It forms a semicircle. So it could be like this, or even from the bottom like this. Okay, or maybe you have a straight line like this. From here to here, as far as anything that forms a semicircle is called angle on a straight line. And in this place, theta is equal to 180. Okay, theta is equal to 180. So that is what we call angle on a straight line. So the next one is which is the last one, which is number 5, is reflex angle. Reflex. Now in reflex angle is angle that is now greater than 180 but less than what? 360. So which means 180 is what? Less than theta, which means theta is now greater than 180, and that theta is still less than 360 degrees. So that is what we call reflex angle. So reflex angle is any angle like this, V part from here to here. Okay, you see how big the angle is. So this is my theta. So we say that if this is A, B, C, we say that what? Reflex angle, sorry. You must put that reflex angle so that the person will not think that you are talking about the one inside here. So reflex angle A, B, C, like this, is equal to what? Theta. So that is how we name those angles. So having done this, now let's talk about how they work, the laws that are guiding all these angles. Okay, the laws that are guiding them. For example, if I have something like this, let me have a parallel line. I want to get everything at once. Let me have a parallel line like this. In fact, let me draw 3 parallel lines. Okay, now what do we mean by parallel line? A parallel line is any line that can never meet, no matter how far you extend them. If I start extending this thing to wherever, they can never meet. We call them what? A parallel line. Then if I have these 3 parallel lines, and then I now have a line that crosses them like this. This line that crosses them is what we call a transversal line. Okay, it's what we call a transversal line. Now, when now there are laws, or there are angles that are formed from this. There are so many angles that are formed from this. Okay, so let's get those angles. No, we represent parallel line with this arrow, show that this is parallel to this and this is parallel to this. In fact, they are parallel to each other. So let me say that this is angle A, for instance, angle B, angle C, and finally angle D. Then here, angle E, angle F, G, H, I, J, K, and L. Okay, these are all the angles I got when a transversal line passes through these 3 parallel lines. Now let's see what happened to all these lines. The first thing that we're going to look at is corresponding angles. The first one we want to look at is correspond. Let's talk about those ones that are equal. Angles that are equal. Yes, let me call it number 1. Angles that are equal. Angles that are equal here, the first angle that are equal is called the corresponding angle. Corresponding angle. You know that, don't forget that this can be represented with angles. Corresponding angles are angles that are in the same position. Corresponding. If you are in just 1A and I'm in just 1B, this line, just 1C, and all of us took first position, we are corresponding. So we are in the same position. So if you look at this very well, you will see that angle A, angle E, angle I are in the same position. So we say that angle A is equal to angle E, which is equal to angle I. And my reason is called what? You must put your reason. My reason is what? Corresponding angles. Corresponding angles. Okay? So let's look for another one that is in the same position. Angle B, F, and J are in the same position. We say that angle B is equal to angle F, which is equal to angle J. And my reason for that is what? Corresponding angles. They are corresponding to each other. So which other one? If you look under, you see that angle C, G, and K are in the same position. We say that angle C is equal to angle G, which is equal to angle K. The same reason is still going. Corresponding angles. So let's look for another one. If you still move under again, you see that angle D is equal to angle H, which is equal to angle L. The same corresponding. We say that angle D is equal to angle H, which is equal to angle L, and we have the same reason. Okay, so that is the first angle that are equal. The next angle that are equal is called alternate angle, number B. Alternate angles. Okay, alternate angles. Now alternate angles are any angles that form n like this. It must form n like this. So here must be equal to here if here is parallel to here. Okay, the next one, they can form Z. They can form Z, either Z like this. Inside is equal to outside. Inside is equal to outside. It must form Z like this. Inside is equal to outside. Or they can form this type of Z. Inside is equal to outside, provided that here is parallel to here and here is parallel to here. Okay, so that is what we call alternate angles. Now let's look for alternate angles here. If I look at Z here, look at Z like this. I see this Z that I just drew. Now inside is equal to what? Outside. So we simply say that what? Angle C is equal to angle E, and my reason is what? Alternate angle. So the next one, look at another Z that I can draw. Z like this. So this inside is supposed to be equal to outside. So we say that what? Angle D is equal to what? Angle F. So we have considered these two parallel lines. Now let's consider these two parallel lines. Considering these two parallel lines, I'm having that what? G is equal to I. So angle G is equal to angle I. So H is equal to J. So angle H is equal to what? J. Now let's consider these two parallel lines, the first one and the last one. If you consider the first one and last one, we will see that what? Angle C is equal to angle I. Look at the Z, the big Z. Look at the big Z here. This is the big Z. I see that. So inside is equal to outside. So we say that what? Angle C is equal to what? Angle I. Okay? So the back, the other Z. So angle D is equal to angle J. So angle D is equal to what? Angle J. So my reason for all these things is what? Alternate angle. Alternate angles. Okay? So that is that for alternate angle. Now the next angle we look at that are equal is called vertically opposite angles. Vertically opposite angles. Okay, now vertically opposite angles, they form X like this, whereby anyone that is opposite to each other are equal. Here is equal to here, and this side is equal to this side. So we call it vertically opposite angle. So if you come to these dots now, you are seeing that what? C is vertically opposite to A, is vertically opposite to C. We say that A is equal to C. D is equal vertically opposite to B. We say that B is equal to D. You come to this next point, you say that what? E is equal to G, and F is equal to what? H. We come to the last one. I is equal to K, and what? J is equal to L. And my reason for all this thing is called what? Vertically opposite angles. Okay, so these are angles that are equal. So since we are done with angles that are equal, now let's go to the next angle. Angles that sum to 180 or that are supplementary. Okay, number 2 is what? Angles that are supplementary. Please, supplementary means that their sum must be equal to 180. Okay, no, so angles that are supplementary are called angles that sum up to 180. So now the first one that we'll look at is called angle on a straight line. Sum of, if I sum, because you are summing them, sum of angles on a straight line. So now let's look at any straight line we'll consider. Look at the first straight line we want to consider. If you consider this straight line now, straight line AB, straight line CD, straight line EF. So if I consider straight line AB, we will see that what? If you add A plus B, that it will form a semicircle. I told that anything that forms a semicircle is angle on a straight line. So if you combine A and B, it must be equal to 180 because it forms a semicircle. So now, if you consider B and C, straight line, let me call this straight line MN. If you consider straight line MN, we see that what? If I can add B and C is equal to 180 because it will give me a semicircle. So B plus C is equal to 180. So if you consider the under of A and B, you see that C and D is equal to 180. So C plus D is equal to 180. So if you consider the other one now, you see that what? D and A is equal to 180. So A plus D is equal to 180. So my reason for all this thing is still what? Sum of what? Angles on a straight line. Okay, so I'm not done with sum of angles on a straight line. I'm done with the first point. So at the second point, do the same thing. This plus this is 180. 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 And at the last point, do the same thing. So anything that can give you half of a circle is called angle on a straight line. So the number 2. So number 2 is called the allied angles. Allied angles. Okay? Allied angles are supplementary. And how do you know allied angles? Allied angles are formed in the same when we have two parallel lines like this, opposite each other like this, inside like this, opposite each other like this. So automatically we will say that what D plus E is equal to 1/8. Which other one? Inside. It must be inside. This inside, which is what? C plus F is equal to 1/8. The next one, this inside, which is what? H plus I is equal to 1/8. So the last one now, G plus J. So G plus J is equal to 1/8. And my reason for this is what? Allied what? Angles. Okay? So that is that for sum of angles, supplementary angles. But there's another one that is called complementary angles. Complementary angles are right angles. Don't forget, but I will not put it here because there is no right angle here. So complementary angles are right angle. Any angle that sum up to what? 90 are called complementary angles. But I will not put it here because we don't have any right angle here. So the next one, number 3, which is the last one, are what? Angle at a point. Sum of angles at a point. Sum of angles at, or angles that sum to 360. Let me call it like that. Angles, number 3, angles that sum to 360 degrees. And it's just one. And that one is what? Sum of angles at a point. Okay? Sum of angles at a point. And that sum of angles at a point form a complete circle. Anywhere you can get a complete circle is called sum of angle at a point and is equal to 360. You see, if you combine A plus B plus C plus D, they will give you a complete circle, which is what? 360 degrees. The next one, if you combine E plus F plus H plus G, it must give you 360. The next one, if you combine I plus J plus K plus L, it must give you 360. So my reason for all these things is what? Sum of angles at a point. So if you look at this now, it is very easy to remember. The first one, they are 3 in number. The first one is called angles that are equal, and they are 3. Then you go down to the second one, angles that are supplementary, they are 2, which is what? Sum of angle on a straight line and allied angle. Then the last one, which is what? Angles that sum to 360, they are just 1. In fact, you can turn it around that the first one is sum of angle at a point. That is angles that are 360. Angles that sum to 360, which is number 1, they are 1 in number. Number 2, they are 2 in number. Then number 3, which is angles that are equal, they are 3 in number. And the 3 of them are what? Vertically opposite angles, alternate angles, and corresponding angles. Okay, so let me check my time. Okay, so we still have time. So let us solve some questions to illustrate all these things we have done. So once you can remember all these things, there is no question that you cannot solve when it comes to plane geometry. Okay, there is no question that you cannot solve when it comes to plane geometry. So let us look for some beautiful questions and solve them. So the first question we want to solve, question number 1, is giving us a right angle, and I have this. They said that here is what? 3x degrees. They said that here is 5x minus 2 degrees, and they said that the last one is 2x minus 2 degrees. Then I say find the value of x. Okay, sorry, they said find the value of, they said that here is a b e c d. Then I say find angle e b d. Find angle e b c. Sorry, find angle e b c. Find angle e b c. Okay, we want to find angle e b c. That is from that line E to the line C. These are all the things we need to find. But before that, let us find x. How do you find x? You say that what? 3x, which is the first one, plus 5x minus 2 plus 2x minus 2. Everything must be equal to 90 degrees. What is my reason? Right angle. Don't forget, anything that is perpendicular to each other must be what? Right angle. So we say that what? Right angle. You can write it like this. Right angle. Or you spell it right angle. That's my reason. So let us add all the x. I'm having 3x plus this is 8x plus 2x, that is 10x. Okay, I'm having that 10x, this is minus 2 minus 2, which is minus 4. So 10x minus 4 is equal to 90 degrees. So therefore 10x is equal to what? 90 minus 4. So 10x is equal to what? Sorry, 90 plus 4 now, right? 10x will give you what? 94. So therefore x will be equal to what? 94 divided by 10, which is 9.4. So if x is 9.4, to find this angle, you will not tell them that what? Angle EBC is equal to, combining these two angles, is equal to what? 5x minus 2 plus 2x minus 2. So what do you have? This and this will give me 7x minus 4, which is what? 7 bracket 9.4, then minus 4. So you do the calculation and you get that. Emma, please, can I get my calculator? Okay. So that is for number 1. So you multiply that and get the result. So when you say this time this, okay, thank you very much. So we have 9.4 times 7, we get the answer, which is 65.8, then minus 4, which is what? 61.8 degrees. As simple as that. So the next one, number 2. Number 2 said, number 2 gave us a straight line like this, and then gave us a line like this. This one comes this way, and then the last one goes this way. So they say that here is 20, here is 2x, here is 5x, and here is 3x. Okay, so they now say find x. Find x. Okay, this one is very simple. You see that since we have a straight line like this, look at a straight line, and I know that anything that forms from that straight line till you meet the straight line again and is forming a semicircle is called sum of angle on a straight line, and is equal to what? 180. So from any line to the same line forming a semicircle is called angle on a straight line, and is equal to 180. So if I say 20 plus the 2x plus the 5x plus the 3x, I will say that they are equal to what? 180. What is my reason? Sum of angles on a straight line. Okay, these are supplementary angles. Another supplementary angle that I did not tell you is sum of angle in a triangle, but we don't have triangle in that stuff, so that is why I didn't say that. So let us add it. This is what? This plus this is 10x. So I'm having 10x is equal to 180 minus 20. So 10x is equal to what? 160. So therefore x is equal to what? 160 divided by 10, which is what? 16 degrees. As simple as that, we've gotten our x. You see, these are very, very simple questions. So the next one we'll look at is okay, look at another one we have. We have this, and they say that here is 45, and they say that here is 3 in bracket of x plus y degrees. Okay, and there's another one that goes this way, and they say that here is y, and they say that this side is a 5x plus y degrees. Okay, they then say we should find, they say find 2x minus y. Okay, we should find 2x minus 1. Now before that, let's look at this. Look at a straight line AB, for instance. This is a straight line, and if I can move from this side to the other side, I'm seeing half of a circle. So I can tell them that 3 in bracket of x plus y then plus 45 is equal to 180 degrees. What's my reason? Sum of angles on a straight line. That's my reason. Okay, so if I open bracket, I will see, or if I open bracket, I'll see that what 3x plus 3y is equal to what 180 minus 45. So therefore 3x plus 3y is equal to 180 minus 45 will give you 135. But if you look at this very well, you see that 3 can divide everybody. So if 3 divides everybody, if I divide by 3, divide by 3. So if I divide by 3, I'll be having that what 3 divided by this one, I have x. 3 divided by this one, I'm having y. 3 divided by this one, I'm having 45. Okay, so this is my equation 1. Now let's look at equation 2. Equation 2 is going to be under it. From here, moving like this, you touch it. Another half of a circle. Okay, which we can easily tell them that what? That 5x plus y plus this y again is equal to 180. And what's my reason? The same reason with this. Same reason. Okay, so what do we have now? We'll be having that 5x plus 2y is equal to 180 degrees. So this is what? Equation 2. Nothing can divide everybody. Equation 2. So we will now solve equation 1 and 2 simultaneously. Okay, so let us solve equation 1 and 2 simultaneously. So we have equation 1, which is what? X plus y is equal to 45, and equation 2, 5x plus 2y is equal to 180. Okay, so how do you solve simultaneous equation? Try to make any one to be the same. How do you make them to be the same? If you want to eliminate, let's use the elimination method. If you want to eliminate x, use the coefficient of x in equation 1 to multiply everything in equation 2, and then use the one for 2 to multiply everything in equation 1. So equation 1 will be times 5, while equation 2 will be times 1. So let's do that. 5 times everything will give you 5x plus 5y is equal to 5 times 45 will give you 90, right? Don't know. 45 times 5. Okay, I'm having 225. Okay? Then 2 times, sorry, not 2 but 1, because the coefficient is 1. 1 times everything is something. 5x plus 2y is equal to 180. So let us subtract. See that they are now the same. Once they are the same, you can subtract. And if you subtract, it will eliminate. So this minus this is gone. This minus this is giving me 3y is equal to 225 minus 180. I'm having 45. Okay? So therefore my y is now what? 45 divided by 3, which is what? Which is 15. Okay? I've gotten my y to be 15. Okay? Now how do you get x? In equation 1, anywhere you see y, put 15. You tell them substitute y equal to 15 in equation 1. And equation 1 says that what? X plus y is equal to 45. So therefore, x plus 15 is equal to what? 45. So therefore, x will now be what? 45 minus 15. So therefore, x is equal to what? 30 degrees. So since I've gotten my x and y, to find this thing they say we should find, we tell them that what? 2x minus y, which is what? 2 bracket 30, then minus what? 45. So what do you have this time? This 60 minus 45, which is equal to what? 60 minus 45 will give you 15. So that is that. So you see, it's very simple. How did we start this? By the same law. And what is the law? The law is angle on a straight line. So let's look at the last question on this. Then we'll now move into more difficult questions. I have this, and I have that here is x degrees, here is 2x degrees, here is 3x degrees, and finally here is 4x degrees. And they say find angle RTS. Sorry, is it? Oh, sorry, that is not the question. Sorry, that's not the question. The question said Look at the question here. They gave us something like this. They say that this is R, T, Q, P, S. Okay? They say that here is X degrees. They now said in the diagram, comma, angle PTQ is equal to X degrees, comma, angle QTR is equal to, okay, is twice as big as angle PTQ, okay, comma, they say angle RTS is 3 times as big as angle PTQ, okay, and angle PTS, okay, angle PTS is 4 times as big as the same angle PTQ, okay. They now said find angle RTS, okay, find angle RTS. Now if you look at this now, it's very, very simple. Now they say that what? Angle PTQ, which is this, they say is equal to X degree, no problem. They now said QTR is twice as big as this. So twice means 2 times this, which is what? 2x degrees. Are you getting that now? So the next one, they say angle RTS, which is this one, is what? Is 3 times this one. So which is what? 3 times x, which will give you 3x. Okay. So the next one, they say what? Angle PTS is 4 times PTS, which is this side. So they say that here is what? 4 times that same x, which is 4x. So we are done. So we tell them that what? X plus 2x plus 3x plus 4x, all of them is equal to what? 360 degrees. Why? Because it is forming a complete circle. If I add everything, I'm forming a complete circle. And when you form a complete circle, we call it what? Sum of angles at a point. Okay? As simple as that. So let us add now. This is 5, 9, 10. So this is 10x is equal to what? 360 degrees. So therefore, x is equal to what? 360 degrees divided by 10, which is what? 36 degrees. But I'm not looking for x. They say we should find angle RST, angle RTS, which is 3x. You tell them that angle RTS is equal to 3x, which is equal to what? 3 times 36, which is equal to what? So we have 3 times 36, so which is 108 degrees. 108 degrees. As simple as that. So let me check my time. Okay, we'll continue with the more difficult question in the next video. Please, thank you very much for watching. Consider subscribing and comment. Drop your question in the comment section. Bye bye.